This is Andy Bloom, and I'm going to be presenting on web components, what they are, how to write them, and then how to use them within Drupal. So before we get too far into this, when I'm talking about web components here, I am using the term for the suite of features that's been added to the native web platform. I'm not talking about, UI components or your components within Storybook or anything like that. Ripped directly from MDN. As developers, we all know that reusing code as much as possible is a good idea. This has traditionally not been so easy for custom markup structures. Think of the complex HTML and associated style and scripts you've sometimes had to write to render custom UI controls, and how using them multiple times can turn your page into a mess if you're not careful. Web Components aims to solve such problems. It consists of three main technologies which can be used together to create versatile, custom elements with encapsulated functionality that can be reused wherever you like without fear of code collisions. So that's a lot in 2 paragraphs. So we're going to break that down a little bit. The three main technologies it mentions are custom elements, shadow DOM, and template and slot elements. Custom elements lets developers define new custom HTML elements and their intrinsic functionality. So you can think of the idea of common UI patterns we might have. Accordions is what I'm going to be demoing. There's no native accordion HTML element, but with web components, we can make them. The second technology is shadow DOM, where developers can add additional markup rendered outside the main document or hidden within that custom element to keep internal structure consistent. This can also help avoid styling collisions, as all of the styles that are needed for within that custom element and its shadow DOM are stuck inside of that custom element and its shadow DOM. It doesn't leak out. And in most cases, styles from the global page don't leak in. And then third are template and slot elements. Developers can define templates for that shadow DOM markup, and they can create slots where content that's outside of the custom element can be used within its shadow DOM markup. So we'll get into each of those. So with custom elements, what we start with is we define a new class in JavaScript extending the HTML element class. We can see here just how easy that is. We define a class myElement extending HTML element, and we put all of the internals inside. And then second, we register it with the browser's custom elements registry. There is a custom elements window object with a define method where you can pass in, this is the exact value within the tag, and then this is the name of the class that defines how that works. And then we use it like any other normal HTML element on the page. Within there are several default methods that we can define in our element. We're going to start with a constructor. Every class is going to need a constructor to instantiate individual instances. You're going to have a connected callback, which is a callback method that's invoked when the element is added to or moved within the DOM. So if you were to do a clone node or document create element and then this tag and it adds it into the DOM, it's going to call connected callback. Disconnected callback is just when you remove that from the DOM. And there's attribute changed callback, which is invoked when an observed attribute is changed. And then we have a get observed attributes method, which just returns a list of the attributes that should trigger that. And so we can say, we don't care if anybody ever changes the class, but if we have the specific attribute we're looking for, we can invoke a callback when that attribute is changed. As an example, I've created a demo accordion element. And here it is in just vanilla JavaScript. We have a myAccordion HTML element. We have myAccordion items, but we'll get to that in a minute. And in the JavaScript, the myAccordion extends HTML element. And you can see down here, we're adding that to the custom element registry. And within there, we have our constructor. Your constructor should always call the super method so that we get all of the constructor methods all the way up the inheritance chain. And then for every accordion that is added, it adds an event listener to itself, listening for this custom element, which we'll see where that comes from later. And it responds with this onAccordion open method, and we're binding this instance of it to that method. And then we handle some stuff here so that when we open and close our accordions, when we open one, it closes all the others. That's all it's doing. It's handling that and telling all of the other items to close. So this is a custom element. This is a web component. This is as easy as it can be, the minimum amount of JavaScript to do a really basic element. Now, this is just the My Accordion piece. The My Accordion item is a little bit more complex, and we'll get to that in the next section here. The second technology is the shadow DOM, which is, in my opinion, the hardest part of doing web components. The shadow DOM is a document fragment. And so you can imagine, you can almost imagine it as a separate document entirely. It just doesn't have all of the same settings and same abilities as your global document. The browser is going to store your page document as one thing, and it stores the shadow document as a completely separate thing. And then you have what's called a shadow host and a shadow root. And so what we have here is, if you're looking at this entire thing and when it finally renders, you have the global document, you have your shadow host, and then below that, it's going to render the shadow tree. This helps with encapsulation, which prevents CSS and JavaScript from leaking into or out of our component. The shadow DOM will completely replace the component's children elements in the rendered page. So if our shadow host had any children here, when it finally gets rendered, the shadow tree replaces all of those children. This sounds like it's going to be a slight problem, because how do we render things within our shadow tree that we want to keep within our shadow host? And that's where the third technology comes in a minute. As I said, this is the hardest part, in my opinion, of creating web components. It typically stems from the shadow tree and the main document being separate. Adding a shadow DOM to our element is fairly easy. It's easy to create a shadow and add it. It's just how you use it and the problems that can arise from how it works. Within the constructor, we do this dot attach shadow, and then we set the mode to either open or closed. An open shadow DOM just allows JavaScript into and out of it very easily. You can go to an element and say dot shadow root, and then boom, you've got your shadow tree right there. If it's closed, element dot shadow tree returns null. And I don't know of a way to get to the shadow tree from there. There might be really hacky workarounds that are weird, but the idea is that with a closed shadow root, even globally scoped JavaScript cannot penetrate into this element. And then the other option is delegates focus, which is a Boolean true or false. If it's true and a non-focusable part of the shadow DOM is clicked on, the shadow DOM will attempt to delegate focus to the first focusable item in that document tree. And that way, if you have something and a user clicks on it and it's not a focusable item, it will pass that focus to within the shadow DOM, and then focus is normal and maintained. Shadow DOM makes some things hard. CSS rule sets from the global scope do not penetrate, but CSS inheritance does. So if you set a property within your shadow DOM of font family inherit, it's going to inherit the font family that's been defined in the upper scope of CSS, but you can't write CSS to target something in a shadow root. It doesn't work that way. It's only applying to the tree that CSS exists in. And then JavaScript, because the shadow DOM is a separate tree of document methods like query selector won't get elements inside the shadow DOM. So if you wanted to do something to all buttons and you rendered a button inside the shadow DOM, you're not going to get that button along with all of the buttons in your main document. The example for this one is going to be the My Accordion item. And this one is a little bit more complex. But we've got in our constructor, we do our super, we attach our shadow mode of open, and then I have a render method here that I'm using. And we're attaching an event listener to the shadow root. The click event bubbles up. If you were around for the event JavaScript thing I did a while back, bubbling is mentioned there. If you weren't there for that, I recommend looking that up. We have a property of open here, which will just toggle between true and false. I have a click handler event, which is going to create that accordion open event and let it bubble up. It's just a custom event there. It bubbles up, it's cancelable, it's composed. It has detail of what item is being clicked and whether it's open. And then we dispatch it, and then we re-render the element. And then on our render method, we're just setting the inner HTML of our shadow root. This is perhaps not the best way to do it, the way that would be recommended from the spec, but it is a way to do it. And I would not today write a web component in vanilla JavaScript. We'll get to the framework that we would use later. classes, all that kind of stuff in here. And so then what we can look at is if we open this up in our inspector, what you'll end up seeing is we have our My Accordion with all of our items, which matches our HTML. And if we expand one of these and look at it, all that's inside of there in the main document is the text of that accordion. What's happening is within the shadow root, we are rendering a new style element with our CSS styles. And these are the styles that apply within the shadow root. We render a new button with an H2 where we're putting in the value of the title attribute. So if I change this accordion 2 to accordion 2, within our buttons H2, we change that value right here. We have a slot. We'll talk about what slots are in a minute. And then we have a div for the accordion content and another slot there, which is going to show our content. So our third technology is templates and slots. In the time that we've been doing web components on IBM, we haven't done a lot with the template element, but slots are extremely common. And templates are going to let you declare your shadow DOM's markup within the main page content. So like I said, I wouldn't normally set the shadow DOM's inner HTML to match some string. You would use the template element and then grab the content from that. And we'll look at that in a second. And slots are used to what the term is reveal children of a shadow host as if they were a part of the shadow DOM. So where I was saying earlier that the children are completely replaced by the shadow tree, if we put a slot element in there with no name, all elements that don't have a specific slot defined will sit within that slot. And so what we end up seeing when we render this is we have our main document with our shadow host, which leads us into our shadow tree, and our slot element reveals the child of the shadow host. Here's a bigger picture of that in case that was too small. But again, we have our main document, the shadow host, the root attaches to the host and replaces all of its children. They're still in the DOM, it just doesn't render it. And then once we add a slot to that shadow tree, the children of the shadow host sit and are revealed within that slot. So over here, what we can do is if I go in here in console and so if I do a document query selector, no, not command value, query selector for the template element. I guess let's save that. Our template element right here has the markup of something that we could do. And what this will never be rendered in the page. The user agent of all browsers hide template elements. They are display none, so they don't show up in the accessibility tree. They don't show up in the rendered page. But because they're accessible via JavaScript, what we can do is we can say template.content, and we get that document fragment. And so we can use that. And if there are, if you're clever about how you do it, you can then set dynamic things in there, classes, you can do you know, all that kind of stuff. And then once you have that, obviously we can do, you know, content dot query selector h1 and get the h1 of our document fragment. And so we could add classes that way through all of our various document methods that we would expect to exist on the document also exist on the fragment. So we can do a query selector of just that fragment. And this would be similar in Drupal to writing a behavior and using the context value within a behavior. So there's our template. And again, if we look at this in the inspector with our accordion 2 item, I have a slot named icon. Named slots only get content that is told to slot into that slot. That's a lot of the usage of the word slot all at once, but I'll show you what that means in a minute. Slots without names get all content by default. So text nodes get slotted in there, elements get slotted in there. Anything that shows up in your inspector is going to be a node. They will all get slotted within our first accordion item, if we collapse the shadow root, you can have an SVG here, and I've defined the slot attribute as icon. And so if we open the shadow root of this first one, we can see slot name icon reveals the SVG, and the accordion content slots everything else. So that within accordion 1, we can see our SVG up here where we want it. And so we could customize whatever icon we want to have in there. And then the template is just hidden up here with its content. And so you can see the document fragment there and grab all that.
When you said like you could be clever about what you put inside of a template so you can dynamically replace, is there like a templating language that's defined by the browser, or like what did you mean by that?
So all you would have to do really is think about what do we want customized in here. And so we could do, for example, within our template ID accordion title and ID accordion content. And then when in our JavaScript, where I'm doing, let's see, where was it? When I'm setting the inner HTML to this, what we could do instead is say get template.content from the global scope, and you can, we could accordion template. And so instead of writing out in the class here, just in a template literal, all of that stuff here, I could put my styles up in my template in the DOM. And then all we do is when we create this, we get that template content and we go and we say, okay, template.query selector, accordion title, and then we can add our own classes. We can do whatever we need to do to insert this, our accordion's title into that H1, replacing its inner text with our title attribute. And so it's just a matter of keeping a reference in the HTML to the template you've defined. It's all just HTML is all it is. And so you're saying, hey, here's this chunk of HTML. How can we be clever about, I want to know exactly what element I need to put my title in, where my SVG goes, all of that kind of stuff.
Cool.
Does that answer your question?
Yep, thanks.
Mm-hmm. Yeah, just a quick one, Andy. The same way how you did the how the H2 dynamically update if you were to change them in the HTML structure, does that same rule apply to the template stuff, or are those like one for one? If let's say if we have multiple templates, do those also update all the template I guess content?
So the way that this is handling this dynamically, so that when I edit this, what's actually happening is when I do accordion 1 to 1, when I do that, what's actually happening in the JavaScript, let me collapse this, is I have static get observed attributes, and I say, hey, when the title updates, run this attribute changed callback, and these are the name of the attribute, the old value of the attribute, and the new value of the attribute. And all I'm doing is say when a attribute that I'm watching gets changed, just run the render function, which is going to then redo all of the logic to handle that. So this is not perhaps the most lightweight and performant way to do this. It is a way to do it. Obviously, it updated to accordion 1 there, but it's setting the classes. It creates the string that sends it to the inner HTML, and then I'm just parsing in. If it's open, rotate 90 degrees. Put the title in, and then add the classes into the div here. And that's just handling the open and close action, toggling the icon, and then displaying the content.
Okay.
So instead of just setting all of this in a string here, what we could be doing is we could be getting template.content and then replacing the pieces that need replaced.
Gotcha. Okay.
Any other questions before moving on? Cool. So like I said, I would not write today a web component with vanilla JavaScript. You obviously can. You can do it very well. But what we've been doing with IBM has been using the, and I guess before we move on to that, you will get some new tools when you start working with web components, you'll get some new CSS. You get the host pseudo selector, which when in a style that is scoped to a shadow root, will select the element that the shadow root is attached to. You can get host context, which is a little bit more complex, and I don't think I've ever used it, and I don't off the top of my head remember what it is, but you do get it. And then slotted, you can style the element that is slotted. You can't pick any of its children, but you can get to it. So if we jump back to this real quick, our styles within the shadow tree, host will select this element, and slotted will select this element. If this has any children down here, we can't impact those, but we can impact one level above the shadow tree and one level out of the shadow tree. And that's the extent of the CSS that we can write and impact from the shadow tree outward. With JavaScript, we get template.content. So you select your template element. The content property is it's actually a getter method, and it gets you the document fragment. Element.shadowRoot. If I run that, it will send me into the shadow tree. If I am on an element and I use owner document, it will go to the globally scoped document regardless. So if I run this in the global tree or in the shadow tree, owner document sends me all the way to the top of all trees. Element.getRoot node, if you're in a shadow tree, will send you to either the document fragment root or to the host. I don't remember which one it is. And then there's a slot change event that fires anytime you put, anytime you move something into or out of a slot. Obviously, closed shadow roots might block some of these because getting into and out of the shadow root, if it's closed, is more difficult. So with IBM, we've been using lit element, which is a framework library. I always get the two messed up. It's a library from Google for building web components, and it adds some extra features. It gives you some basic boilerplate stuff and adds a lot of reactivity to your stuff so that you don't have to worry about, oh yeah, I need to watch for this property too, and oh, I'm going to make a new property, I have to watch for it. When you start using lit element and you start using it the way that they define properties, they just automatically get updated in both places, both the definition of the property and telling the component, hey, watch for this property to change. The lit bundle itself, what it's going to end up doing is instead of extending the HTML element, you extend the lit element. And so the lit element is going to bring along 5 kilobytes of that kind of basic feature to your component. The way that I have it set up in Drupal right now is where the lit element is its own module, and we're going to import it from other places. So instead of every element adding another 5 kilobytes, we add that once, and then all of our individual ones just add on top of that. So same component, identical, but built in lit. You know, it's the same thing here. And what this is doing in JavaScript is we're going to import a couple of things using Skypack here. So if I refresh this page, you'll see this flash of unstyled content. That's just waiting for the Skypack stuff to come in. If you have this bundled up, it's not going to do that, and you'll see that when we get to the Drupal one. So what we're going to do is it brings along. This is also in TypeScript. I didn't do a ton of TypeScript here, but it has it. And then we have the decorators. So custom element, my accordion. Instead of declaring your class and then doing a manual registration, we use this decorator, and then we keep it right here with our class definition to say, hey, this is what's going to be in the HTML tag. And now let's look at the class. We still have our connected callback that gets passed through. That is custom stuff. The render method they have is similar to what I've done, but is, you know, made extra performant. And then let's see here. Yeah, properties. The @property decorator has some options. You can give it an attribute. So this one is the attribute title, reflect true. What that means is if I change the title property value programmatically, it will reflect that back into the DOM. So instead of just saying, I'm going to change it here, if I change it in the console, it will also update it in the DOM in case you're using that property for styling as well as functionality. property Boolean true false. We have our click handler, which is just a private method. We have our render stuff. We get tagged template strings, which is nice. And so we can do this. And then in IBM, we're using Sass. I didn't want to get that all set up for this demo. But what we've done is we've written all of our CSS in Sass files using the various includes, imports, whatever. And then we just import that and set the static styles property to that. But you can also use the CSS tagged strings here. Their documentation is pretty good. I like it. It's been pretty easy to find things when I don't know what I'm doing. There's not a ton to show here because it's basically the same element just written in a library. Are there any questions about lit element kind of being extra seasoning on top before we get to the Drupal stuff?
Yeah. So are lit elements, is there a compilation step needed to kind of like JSX to kind of process your web components, or are they just like a pure class that you can inherit?
It's a good question. They can be a pure class, but they do need to extend the lit element class. So this is what's coming along with that library bundle. So you could do this all in just JavaScript and ship your file directly to the browser. But you would also need to make sure that you have shipped the lit element class to the browser and that it's available to you globally. So you do need to be a little bit careful. The decorators here are something that I've read might be coming to JavaScript. And obviously, if it's TypeScript, you're going to have some kind of a compile step. This is all with IBM setup. It's all going through Rollup and Webpack, I think, and Storybook and a whole. So they have a gigantic build step to get all of this ready and a good development setup. So there's a lot of work to set it up for development. But when it's ultimately shipped off to the browser, it's just compiling down to regular JavaScript, and you add this one extra class in there. Is essentially what it is.
Cool, thanks.
Mm-hmm. Any other questions about lit before going on to Drupal? All right, got about 9 minutes left. That should be plenty of time. Drupal, okay. So the traditional rendering from Drupal, we have Twig, which is just the templating engine for PHP, which lets us create the HTML and to borrow a term from React, kind of hydrate it with data from our database. We pre-process all that. We feed it into the Twig template. We have our libraries API, which lets us define the CSS and JavaScript, and we can use attach library to attach CSS and JavaScript in groups and have more granular control of our extra assets. And we have JavaScript behavior, which lets us define scoped functionality that can be recalled as needed due to big pipe rendering or other asynchronous JavaScript functionality like AJAX calls. With web component rendering, we still can use all of that. We don't have to use all of that, but we can. With Twig, we're still using Twig and our pre-processed variables, but instead of authoring our HTML and putting all of the complex UI markup in our Twig, we can keep all of that scoped within the shadow DOM and simplify our Twig markup. And then our slots can handle the inner complexities. The shadow DOM and the slots can all handle the inner complexities of the UI component. With the libraries API, we're still going to use it to define the necessary JS files we need. The file that we're going to have creates the custom elements class and registers it with the browser's custom element registry. So we're still going to use the libraries API to bring all of our assets in that we need. They just are typically going to be bundled a little bit tighter as maybe Sass or as JavaScript. And then with our behaviors, since all of our functionality is within the element, we don't necessarily have to use behaviors. We don't have to worry about if we're adding a new one later to reinitialize all of the event listeners that may need to exist on it, because all of that logic is already in the class that we've already sent to the browser on page load. So JavaScript behaviors aren't, I would say we don't use them for web components. You can still use them in Drupal. They're not going to interfere in any way, but you don't have to set up a behavior for your web component to reset up every time you bring a new one onto the page. And we can also avoid the problem of having to use the once library. So our example, I've got a tugboat set up. And what we've done is I've got nodes. Accordion 1 is a node of type accordion item where it's got a title like a normal Drupal. Literally all I did was set up a new content type called accordion item and used its default title and body fields. So the title is accordion 1, and when you open it up, it just works. This is then a view, and then the view wraps all of our separate accordion items with that my accordion kind of parent container. Let me log in and I'll show you what we've got here. And I'll give all these links out when I save the recording to the discuss thing. The username and password here is admin, super secure. So our structure, we have our content type, accordion item. What fields do we have? We have the default entity title, and we have a body field. With our view, we have our accordion demo here. It's simply a unformatted list of the full content. And then in our twig templates, it's just wrapping it in that my accordion. I should have had the code open. I don't at the moment. Let's see here. GitHub.com, Andy Bloom. Drupal nodes. Web components. So in our template, our accordion item node just renders this. We're going to attach the library, and we're going to let Drupal handle when it needs to call in the JavaScript. We say my accordion item. We put our title in as the node label, and we render our content in there inside of it. And we let all of the other complex stuff happen in the JavaScript. For our view, we just wrap our rows in the my accordion, and we let it all render with the JavaScript. Do I have any other templates? What do I do with that one? I don't remember what I did with that one or why it's there. And then in our libraries file, we're just defining our components here. So I've got a library of component dot, oh, that's what it was hello world. So my accordion is going to pull in always. It's going to go in the header. You don't have to set it up there, but I put it there to try to maximize how quick it gets it. Build accordion.js and accordion item.js, and they're both modules. And then in our, in our theme, in components, I've written our stuff here in lit. It's going to import from lit. It does all this. So this is not TypeScript because I didn't want to handle that. And then in our theme, we have a rollup config that's just going to handle how it bundles that. I don't know rollup, so if you need help with rollup, don't ask me to go to the documentation. This is mostly boilerplate stuff that I copy and pasted either from the lit element docs or stuff that I saw in the IBM repo. And then when it builds, we have our accordion item, we have our accordion, we have our hello world, and then I think we only actually need one of these. I just didn't delete the old ones. But it rolls up that base lit element that it's going to import. So when we get here, it's going to import stuff from the lit element, and then it has everything it needs. And that's basically it. So we get a nice performant thing here. And as you can see, when we load, everything loads in. There are some ways around that. What you can do is in your styles, anything that is not defined, you can set to display none. And then what that'll do, you'll remember that flash of unstyled content. Until it's defined, it won't appear. And so without that, we get that flash of, hey, here's all this content rendered in things you don't know what they are. But then once they're defined, it will display them. We skip that. We just don't display anything until it's defined, and then we can show it.
Quick question about events. So like if you fire a custom event, say in a web component, does it bubble up through the entire document tree, or does it like stop at the shadow DOM or something.
That's
like
a great question. By default, it will stop at the shadow DOM. What you can do though is if you set it to, let's see where we at, click handler in our accordion item, our new custom event, we give it the name, and then if you set this composed, if it's composed, it will bubble up right out of the shadow root all the way through the rest of the document. So if this is false, it stays contained within your shadow DOM, but setting composed to true lets it escape and bubble outside.
I had a quick question I posted, and Chris already answered it, but be good to see it. If you disable JavaScript on that, does it just automatically open the content? In other words, is the content available for the user?
Yeah, so that's a great question, because obviously if we don't have JavaScript, then can we view the content? If I put this in the debug mode real quick, and then I disable JavaScript and refresh the page, this is how it loads in. So the titles of those accordions don't appear because they exist only in the shadow root, and the shadow root doesn't get attached to a custom element that doesn't exist because it doesn't have JavaScript to be created. So if you're creating a website where you definitely need everything to still be hyper accessible without JavaScript, obviously you're not using React, you're not using Vue, you're not using any of the major front end things, and you probably want to avoid web components unless you want to get really, really clever about how you're going to handle things. I imagine there are ways to have JavaScript get you around it. But yes, everything that's in the DOM still gets rendered until the shadow DOM comes in, and then it replaces all those children and slots them out and everything. But the stuff that is explicitly defined within the shadow DOM won't ever render without JavaScript. Thinking about the answer a little bit more, Kat, what you could do, right? And I don't know that this would be the best way to do it, but if you wanted to, you could put content that you want to show without JavaScript in there with no slot definition, and then everything that you want to show that's slotted with an explicit slot name, and then hide anything with the slot attribute. And what that would do then is you could end up rendering stuff that shows without JavaScript, and your CSS would hide anything that has that slot attribute saying, hey, I expect JavaScript to be running here. You end up doubling your markup though in your HTML that you're serving.
Yeah, that could definitely be a workaround. I think the other issue is the arrow. Of course, that could be hidden. But it just
right. Well, but the arrow, remember, has that slot icon. So if we were to add a new rule of slot, and then say display none, then only the content that should be showing, the only content that should be showing should be stuff that doesn't have the slot attribute.
Got it. Yeah.
You then just have to make sure that you author your web component to hide things that would get put in the default slot, and to have the explicit slot attribute for everything that you want to show with JavaScript.
I did actually have one more question.
Go for it.
Does the page have any inline CSS, or is it just like you showed in the component where it's in the inner HTML?
So this page being in CodePen, the way CodePen works is it's just injecting this stuff. But the CSS for the accordion item it's inline in the shadow root. So right now it's not showing, but if I turn JavaScript back on and refresh the page, what you end up with is each accordion item shadow root has supposed to have, or is it in that? Maybe it gets picked up somewhere. I'm not sure, but it was written to be in. Oh no, I'm sorry. This is the lit element one. The vanilla one has the inline styles. So there's also something coming to the spec called, I want to say, composable style sheets, where you can basically create a style sheet from JavaScript, set all the properties in CSS, and then attach that style sheet to the web component. And that way, instead of everything being, you know, inline styles, you have a style sheet that's then scoped to this. If we go to this shadow root, what we can do is, I think it's adopted style sheets. So it's got a length of 1. What's in there? I don't know. This is not an object I've dived into previously. So it's in there. It's attached to that document somehow. I'm not sure how it's doing it from lit element, but the vanilla version is putting this inline style inside the shadow root.
Okay. And that might be an issue. I'm not sure, but with the inline CSS for users that use style sheets, like custom style sheets, like colorblind users or ones with lower vision, because they use custom style sheets on the browsers that change the way the page is viewed, like larger text or changing the background and foreground colors and stuff like that. But I don't know.
Sure.
You'd have to test it. I have no idea if that would or would not work or not. So I'd have to just check it out. But that would be interesting to check out. So cool.
It would be for sure, because I also don't know how much of those styles in a user-defined global style sheet would impact into into the shadow root anyway, whether it was inline styles or not.
Exactly. Yeah. Okay. I'm done. Thanks.